So this is my final project for the robotics course at Seawater. The goal is to program a Tiago robot to pick up jars from a kitchen counter and place them on a dining table in Weebot. So the architecture is intentionally simple considering the time limit. A flat sequential controller, no behavior tree, no state machine. So 5 steps: 1, 2, 3, 4, 5. So initialize the arm, navigate to the counter, pick up the jar, navigate to the table, place the jar. Each step is plugging function that runs until it completes. Navigation uses a proportional controller on distance and bearing arrow, the same P controller approaches introduced in class. The arm control was the hardest part. The key insight is that the shoulder yaw joint never rotates during the grab. Only the shoulder pitch swings down to reach the counter. Of course, you can design more complex maneuver, but for simplicity, I just use this approach. Joint control is time-based, no encoder-based, because the gripper encoder during my test kind of reliable under load. So now let's see how it runs. Let's reset. So the robot starts by setting a safe travel pose, arm raised, gripper pose, open before it moves anywhere. So the same initialization, initial position as the previous homework. So arm raised, gripper open, and it navigates directly to the counter approach position. So I use the same ping pong ball here to navigate. It's just for visualization. And then the arm extend horizontally. Shoulder yaw stay fixed. Only shoulder pitch moves down to reach the jar. And gripper close to 4 centimeters, just enough to hold it. And I designed a 2-stage lift, halfway first, then fully raised. So previously I used one-shot lift at full speed, and it resulted in crashing the physics engine. So this is my 2-stage lift design. Then I navigate through an intermediate waypoint, here, to clear the counter corner, then approaches table from the north. Then arm lowers, and gripper open, jaw lengthens on table. Arm lowers to the height with tail down, gripper opens, jaw placed. So that's it. That's the 80% target for navigation plus pick up and place. So the controller scales to 03 jaws by changing one constant. The number adjusts from 1 to 3. I have not had time calibrating 03 cases, so that's it. Really sorry, but I really do think that's a good learning experience during this lab. Thank you.